everybody, and let's try this one more time. So apologies for the first video that stopped at the 4-minute mark. Let's try polynomial functions and models 5.1 one more time. So first objective, identify polynomial functions and their degree. So a polynomial function is a string of monomials like 5x squared and then 2x and 3. Your degree is the biggest power you can find. The degree here would be a degree of 2. No fractions, no negatives in your powers to be a polynomial. So if we take a look here, there are 2 here that are not polynomials right off the bat. C, because of the fractional exponent, fractional power, sorry, and D, because of the negative power. All right, so to determine which of the following are polynomials, we've done that. For those that are, state the degree. The degree for A is 5. The degree for B is 2. The degree for E is 0, because this is 5x to the 0. Remember, x to the 0 is 1. And the degree for F is 3, because s times s squared would give you s cubed. 3 would be the largest power you could find. All right, try problems 11 and 15. So just a quick summary of polynomial functions. If you have 0, this does not have a degree. It's the 0 function. All right, if you're a constant, your degree is 0. If you are linear, x to the first, your degree is 1. If you are quadratic, x to the second, your degree is 2. So let's take a look at polynomials. Polynomials have 2 things going for them. They are smooth and continuous. So this graph here is not a polynomial for 2 reasons. Because of the cusps and corners here, where it's boom like that instead of a nice curve, and you cannot have any gaps, you cannot have any holes. So lots of problems with that graph. Has to be a nice smooth continuous curve to be a polynomial. All right, let's take a quick look at power functions. So power functions are things like x cubed or 5x squared or 7x to the 7th. All right, all separate here. Notice that they are single terms, just monomials. All right, so you can take a look at some examples there as well. So if we graph some, now we're going to graph some even ones. There's differences between even and odd power functions. If we have x to the 4th, you'll notice that's the widest of x to the 4th, x to the 8th, x to the 12th is the tallest, the steepest. Except for when we zoom in and we get inside of x equals 1. Between 0 and 1, we'll notice that x to the 12th is actually the widest. So if we graph x to the 12th, it goes wide and then takes off steep. X to the 4th would go, oh, come back, would not be quite as flat. Sorry, I don't know why it's doing that with my pen. And then flatten out a little wider. All right, I've exaggerated it there so you can see. So the bigger the power, the flatter it is inside of 1, and then the steeper it is outside of 1. Summary here, pretty much just everything we've said. One nice thing you can add on here is that these 3 points are always going to be on your even integered power functions, 0, 0, 1, 1, and negative 1, 1. All right, and what about the odd ones? You'll notice that we start low and finish high, like an x cubed. And the bigger the power, the steeper we're going to get. So 3 is nice and wide, 11 is the steepest here. And I bet you guessed it, as we get inside of 1, then the flattest one is going to be the biggest, and the steepest one is going to be the smallest power. All right, and those points are going to be 0, 0, 1, 1, but then negative 1, negative 1. We want the point down here for our nice curve. Okay, so let's graph some of these using transformations. X to the 5th. We know that normally it would have 0, 0, negative 1, negative 1, and 1, comma 1 on our graph because it's odd, but we're going to be shifted up 2. So instead of 0, 0, we're going to be 0, 2. Instead of 1, 1, we're going to be at 1, comma 3. Instead of negative 1, negative 1, we'll be at negative 1, comma positive 1. And it's going to be steep, but not super steep because it's to the 5th. All right? How about negative 2x plus 1 to the 4th? So normally we would have 0, 0. We would have 1, 1. And we would have negative 1, 1. But we're going to be shifted left 1 and then we're going to be pointing down and stretched by 2. So 0, 0 is now going to be over here at 0, negative 1. And instead of going up 1, we're going to go down 2. And there you have it. That will be your x to the 4th graph. Try 23 and 29. Third objective, let's find the real zeros. Now, a real zero is the place where we cross the x-axis, otherwise known as 4 different things. A real zero, an intercept, an x-intercept. X minus r is a factor of f. So if we try to factor, we're going to find the zeros. We'll find the x-intercepts. And if we say let's find the solutions, we're also finding the zeros. We're finding the x-intercepts. So we could ask for this a lot of different ways, but what we're solving for is what would make x 0. So let's find a polynomial of degree 3. If we have degree 3, we know we're going to have 3 parentheses with x in them equal to y. And if our zeros are negative 4, then our parentheses is going to be plus 4. Minus 2 will be plus 2, and positive 3 will be minus 3. Let's find that polynomial by factoring, or by multiplying all the way out. The first 2 are going to be x squared plus 6x plus 8. And then if we multiply that by x minus 3, we'll have x cubed plus 6x squared plus 8x. And then all of those times negative 3. So minus 3x squared minus 18x and minus 24. Put them all together, and we've got x cubed plus 3x squared minus 10x minus 24 equals y. Try problem 37. Alright, so going the other direction, let's see if we can identify zeros and their multiplicities. So new word here, multiplicities. Multiplicity is just how many times we have a 0. So in this problem, the degree is 5 because we have 3 and, I'm sorry, can't count right now. Saw that as a 2. 3 and 4 is 7. Sorry. 3 plus 4 is 7, so the degree is 7, but we only see 2 parentheses. That's because x equals negative 4 3 times. So the multiplicity is 3. And x equals 2 4 times. So the multiplicity is 4. Go ahead and try 45a. Alright, let's graph this. So find the x and y intercepts. So the y-intercept is going to be fairly easy. For the y-intercept, we make x 0. Negative 0 cubed. And I'm going to stop right there. Negative 0 times anything is going to be 0. So I know that 0, 0 is on this graph. Let's find the other intercepts. So the x-intercepts. 0, 0 again. We already have that. 3, comma 0. And negative 2, comma 0. Alright, so if we go ahead and use our graphing utility, let's grab our graphing calculator and graph this thing real quick. So we've got negative x cubed times x minus 3 squared and finally x plus 2. Away we go to the graph, and I've got a bad zoom going here. Let's wait for this to finish. Let's do a standard zoom. And there we go. Okay, so we can see that it starts low. It crosses, comes up high. Just guessing, but we know it's got to turn over. It comes back, crosses at 0, 0. We know that. Finishes low. And touches right there. And comes back. Okay, so what point is this? This is going to be negative 2, comma 0. We've got ourselves 0, 0. We've got ourselves 3, comma 0. Now, a couple of things from this graph that we're going to investigate shortly we'll come back to. For now, just try 45b. Oh, I apologize. We didn't do the last one. Each x-intercept is it odd or even multiplicity. 0, 0 is to the first, so that was odd. Negative 2, comma 0. Oh, I'm sorry. To the third. So that's odd. Negative 2, 0 was to the first from here, so that's odd. And this point right here, we'll come back. Notice that it's touching and turning around. That was to the second power here, so that was even. All right, back to it. Try 45b. Okay, so I think you might have guessed here, if you're even multiplicity, we will touch, right? The -3 right here was even, so we're just going to touch and turn around. If you're odd, you're going to cross. All right, so example here, this 0 would have an even multiplicity. This 0 would have an odd multiplicity. Let's add turning points in. A turning point is when the graph turns direction, going up, now we're going downhill, that's a turning point. Going down, going back up, that's a turning point. If you have a degree of, in this case, 2 plus 1 more is 3, the most you can have turning points would be 3 minus 1, 1 less. So the most turning points you could have would be 2. And there you have it again, n minus 1 turning points if your degree is n. All right, so let's take a look at this. Which of the graphs in figure 16 could be the graph of a polynomial function? For those that could, list the zeros and state the least degree the polynomial can have. For those that could not, say why not. All right, A cannot because it has a gap. C cannot because it has a corner. It is not smooth. This one is not continuous. All right, this one could, and it could have a 0 at -2. That could be odd. It could have a 0 at 1. That could be odd. And a 2 that could be odd. All right, what's the smallest odd number we have? 1, 1, and 1. So the smallest degree that B could have would be 3. How about this one? This is going to be odd at -2. It's going to be odd at +1 there. All right, so the smallest degree this could have would be 2. All right, does that make sense, though, in terms of turning points? This has 1 turning point, 2 turning points. All right, so that's 1 less than 3, so that works. This has 1 turning point, 2 turning points, 3 turning points. All right, so the smallest degree this could have would have to actually be 4, because you always have to have 1 more degree than turning points. Try 45C, try 57. Okay, so let's finish up this objective here with end behavior. All right, for really large values, what they're saying here is what happens at the edge of our graph? We don't care what's going on in the middle. It could do all sorts of crazy things as long as it's smooth and continuous. But on the edges, it's going to follow these rules. If your degree is even and you're positive, it will be up and up. If you're even and you're negative, leading coefficient, negative out front, you're going to be down and down. Odds go in opposite directions. Positives start low, finish high. Negatives start high, finish low. Let's take a look at some examples. Which of the graphs in figure 18 could be the graph of x to the 4th? All right, so we know it's a positive, even. So we're okay here, we're okay here, and we're okay here because of the pointing up in both endpoints. So right away, D is out of here. All right, now how many turning points could it have? It could have at most 3 because it's x to the 4th. 1, 2, 3, oh boy, we're out here. 1, 2, 3, that's all right. 1, 2, 3, that's all right as well. So it could be A, it could be B. All right, not sure yet. We could do some more examination, but could be A or B. Try 61. All right, so just a summary here of everything we've talked about. If you want to pause the video and get that down, that will summarize nicely a lot of the things that we've added in. You might already have most of these things in your notes. All right, analyze the graph of a polynomial function. We're not going to do the domain range and find out where it's increasing and decreasing for now. What we're going to do is try to use the zeros and the multiplicity to graph this thing, and the end behavior. All right, so let's start with the end behavior. This is going to be an x to the 2, 1, 1, x to the 4th graph. And all of my x's are positive, so this is going to be positive. So let's talk about our end behavior. End behavior is going to be up and up. All right, let's talk about our zeros. We know we're going to cross at -4. And I take that back. Since it's even, we're going to touch at -4. We're going to cross at 1, and we're going to cross at +2. So it should look something like this. Touch, turn, cross, cross. There we go. How many turning points do we have? 1, 2, 3. That's 1 less than 4. We're in business. All right, that's going to be the general shape. And we could go into the graphing calculator and figure out the minimums and the local mins and maxes. But for now, I just want you to try to sketch the general shape. All right, so there's a nice summary of the things we've done. Again, for now, we're not doing domain and range. We're not doing increasing, decreasing. Try 65. Okay, I'm going to go ahead and for now skip this one as well, but just a quick peek at this one. Take a look at the end behavior. This one's going to start high, finish low, can have at most 1, 2 turning points because it's x to the third. All right, this isn't factored. We would use our graphing calculator. We can go over this one in class, how to get the graphing calculator working for us. But for now, just general shape on 83. See if we can come up with that. Okay, last objective. Grab your graphing calculators and follow me through. What we're looking at here is a cubic function of data. So these are a lot of data points plugged in, starting low, turning twice, and finishing high. So it's x cubed because there's 2 turning points. Or starting high, finishing low, same thing though, 2 turning points, still x cubed. All right, so if we have a bunch of data, can we come up with a nice model to model it, to measure it? So here's what we're going to do. We're going to grab our graphing calculator. We're going to hit stat for statistics. And we're going to edit 2 lists. And we're going to plug these numbers in. So here we go, 0, 5, 10, 13, 17, 18, 20, 23, 25, and 27. And then we'll go over to list 2. Now, if this list already had numbers in it, I could go up to the top here where it says L2 and hit clear. And that would clear that list out. If you have anything in L3 or L4, go ahead and clear it out for now. It's going to mess you up if you've got stuff in there. 128.1, 144, 153.5, 161.2, 162.6. Let's finish up here. 166.3, 178.9. 190.2 and 221.8. Got them all in there. If you get an error, it's probably because you have more numbers in the first list than the second list. So that's something you should always be checking. Okay, we're going to go back into stat. And now we're going to calculate. So in this case, we're doing a cubic regression because we want x cubed. If we wanted a quadratic regression or a linear regression, we'd be solving for x to the first or x squared. So number 6, cubic regression. And here we go. We want to make sure we're using L1 as our x values and L2 as our y values. If we had a third and a fourth list, we could change this if we wanted to, but for now we're okay. Now, it's going to spit out a lot of numbers. Instead of having to write them down, we're going to send this straight into the y1, right? Into the y equals. y1 is a variable, so hit vars. It's a y variable, so over here, and it's part of the function, and it's y1. So once again, variables, y variables, and function, and we hit it right in there. Okay, so it's going to store it there. Let's go down and hit calculate. Now your calculators may look slightly different than that, but the numbers you should get is the same. 0.015 x cubed minus, this is b, 0.595 x squared plus 9.15 x plus 98 just by itself. That's the constant. If you go to your y equals, you see, boom, it's already there. Now, before we do anything, if we graphed this, there's our graph. We don't see a whole lot here. Let's come back to that in a second. What happened to all the numbers? Go back to y equals and go up and turn your plot on. Turning that plot on will create a scatter plot for you. Make sure in your stat plot that you're plotting L1 and L2 because those are the lists we used. Let's go in and change our window to make sure that our x min is a little bit smaller than 0. Negative 10 will work. And our max is a little bit bigger than 27. So how about 30, 35? Our y min, a little bit less than 100. So how about 90? A little less than 100 right here. And a little bit bigger than 221. So how about 230? Now let's go back in there and graph. And look, there's all the dots. And here comes the curve that we figured out is going to fill right on top of it. All right, so there we go. The very last thing it asks is say, okay, predict what the cost of 22,000 text would be. So notice that 22 is not on here. But our best guess would be somewhere in between there. But now that we have a nice function that's in y1, we can go to our table and just go ahead and ask. And so in our table, we'll type in 22, and it'll say 176.3. right what we thought, right in between these two numbers. All right, that'll do it. That wraps things up for 5-1. Hopefully this video worked all the way through for you. We will go over all of these in depth in class. Try those problems. Good luck with all of it.